Welcome to A-Level Statistics at Sixth Form College Colchester. The aim of today's presentation is to give you an overview of the course that we offer. Why study A-Level Statistics? Well, hopefully you've found yourself here today because you think it's potentially a very interesting subject to study. We certainly agree it is an interesting subject, but most importantly, what it allows us to do is develop the skills needed to work with and interpret the numerical data that surrounds us in the world today. It's very difficult at the moment to put on the television without seeing some news regarding some data, not all necessarily very cheerful at the moment, although the current situation is constantly changing, but we'll be affronted with all sorts of numbers at the moment. And what we miss in a lot of this is we read the headline and we see what's going on, but quite often we miss the finer detail of, well, okay, this number you've got in front of you, is it an actual figure? Is it an estimate? Does it come from the whole population? Is it measured properly? Or have they somehow gone out and collected a group, a sample of data, and then extrapolated that to the population at large? Can we actually take all of the values we're looking at face value? And being able to answer those questions makes you a decent statistician. Okay, so we're not necessarily ready to dive straight into that analytical phase yet, but we do have some A-level subjects in mind that we'd like to study. So the other advantage of A-level statistics is it's actually a really good supporting subject for other subjects. And if you have a flick through your prospectus, you'll see there's a group of subjects that actually promote statistics as a useful topic to do alongside. Psychology, sociology, environmental science, and all the earth sciences, geography and geology as well. Sciences, if you're looking at your biology, if you're looking at chemistry, certainly if you're considering medics as a potential career or veterinary science, you're going to be doing some statistics within the A-level, but actually taking that a step further as well. We've got all the business field of things, the accounting, the economics as well, and then there's the slight other bunch, which is things like the graphic design and the computer science and electronics, where obviously the link is not quite so clear, but there is some useful statistical skills that you can develop on the A-level stats course that would be of benefit in those subjects. And actually beyond A-level, if you're considering doing any of those subjects at degree level or beyond and taking it into a full career, then having an A-level in statistics is going to be a good advantage, because you're going to meet some of the skills that you need that you're going to meet at university. So why not meet it at A-level first and be prepared to take it forward in the future? So not just at university, but actually beyond, and even if you're not going to university, in employment, data handling, ability to do statistics are really, really useful. Selection of very statistical job roles are given on screen. Some of them are quite complex and require quite a lot of detail. So if you'd like to explore those in a little bit more detail, there's a link on the screen to the Royal Statistical Society. But if you're considering other careers as well, things like weather forecasting, emergency planning, disease control and prediction, quite a current topic. Obviously things like medicine, medical research, genetics research, to the extent of political campaigning, risk analysis, quality control, they all include some statistics. They're not necessarily a statistical job, but they do require you to manage and handle data and actually, more importantly, describe and interpret data for others to understand. And that's quite a challenging skill to be able to develop. The aim of this course is to get you en route to those particular career options. Okay, so one of the obvious first questions is, well, okay, what qualifications do I need to get onto the course? Well, these are detailed out in the prospectus. Obviously, you need to be fairly numerate. So a grade 6 or higher at GCSE Maths. If you have studied GCSE statistics and haven't done quite so well on the maths, you've got your 5, but not quite attained the 6, provided you get a 5 or higher in the GCSE stats, you're obviously showing that that numerate ability is there. We don't desperately need you to have the higher skills in the maths, which generally cover the algebra skills, because we don't have that much algebra within the course. There is some, so we need you to be numerate and able to manipulate basic expressions, but we're not looking for that higher level of mathematical skill. What's actually more important to us is your ability to interpret and problem solve. And for that reason, we do need you to have at least a grade 4 in the GCSE English, be it the language or the literature, but we need that level of literacy skill because there is a lot of reading to do and you do have to do some long written answers within the actual exams. So interpretation and your literacy skills are almost as key as your mathematical ability in terms of being able to be successful within the course. Okay, so a little bit of detail about how we deliver the course. Well, obviously we do use some textbooks and we also use some other booklets that we've produced to give you worked examples, questions, exercise questions that you can practice, and then also some embedded exam questions and past paper questions that you can have a play around with and test that your skills up to the level required for that final examination. The link on the screen there gives you access to the Edexcel website where you can go and have a look at the sample papers that they've produced. They're quite wordy in places, so you might be quite surprised at the amount of words as opposed to the amount of numbers that are in there. It is a relatively new course. All of the maths courses were updated in 2017 with the new curriculum changes. So in terms of looking at past papers, there haven't been many. However, the sample paper gives you a good flavour of what's available out there to have a little look at. When we work through the course, at the end of each topic, we have a homework assignment that everybody on the course sits, so we can have a look at how you're doing within the cohort as a whole, so we can monitor your progress regularly, and then we know which topics you need to go back and have a look at and work with. We'll also provide you with additional revision exercises as we go, and we do periodically do a test sort of every half term or so, just to make sure you're still recalling the old material and keeping on top of the new material. It is quite a different process for you to do your exam at the end of the 2 years. So we need to make sure you keep revisiting some of the older material as well. We've built that into the course so it works quite nicely. And in the second year, where first year material is used, we tend to review that first and then build on it, adding the new second year material as we go. So similar thing, first year, we'll look at what you've done at GCSE that we can use and then revise it, rebuild on it, add a bit more to it. And then in terms of other support outside of the classroom, we do have a mentoring scheme. So we have some second year students who volunteer to work with, for say 40-45 minutes a week, one of the first year students, and they get to, second years get to revise the material and the first years get to ask those little questions and little niggly bits that they don't necessarily want to ask in class in front of everybody else. But in addition to that, we do have an open door policy on the workroom. So if you want to come and ask us a question outside of lesson time, if we're around, you can do so. We can arrange for that to happen. Okay, so a little bit of detail about what topics are going to be covered on the course. Well, to start with, logically, we'll begin with bits and pieces you're familiar with from your GCSE maths. Now, if you have done GCSE statistics, you'll have a bit of an advantage because things like standard deviation will be familiar to you. For others, that'll be brand new. But we won't make any assumptions. We'll start from a basic level and bring you all up to the same level ultimately. So some topics you're familiar with: collecting and presenting data. So bar charts, histograms, pie charts, all the usual bits and pieces you've been working with. We don't actually do a lot of drawing of charts, we do a lot of interpretation of charts. We'll also chuck things like the mean, the median, the mode into the mix as well, things that you should be fairly familiar with to start with. So starting with steady, familiar territory. Probability, definitely a topic you'll have covered at GCSE, we'll take that. We do a lot of work with probability, unsurprisingly, on the Statistics A-level course. So we need to make sure those fundamentals are in place, those foundation skills, so that we can start building on them fairly rapidly as the course progresses, because an awful lot of what we do is related to probability. And you'll already be familiar with scatter diagrams, so we'll build on those skills and start looking at, well, how do we find that equation of the line of best fit? How do I make sensible predictions so that everybody in the class can actually come up with the same value, not all of us giving slightly different estimates because our lines are a little bit differing in places. Okay, so once we've reviewed the GCSE skills, obviously the next step is then to introduce some new topics. So one of the important topics that we do a lot of during the course is to look at some probability distributions. And we use those to model populations. So you will have heard quite a lot, if you've been listening to the news lately, about the flattening of the curve. And if you look at the diagram on screen, you'll see the high peak and then the one that's been squashed. And we'll learn all about that curve. That's known as the normal distribution, and it occurs in an awful lot of naturally occurring data sets within the world at large. And unfortunately, epidemic data is one of those things that it tends to refer to. So we'll look at how we model with those. We'll look at binomial distributions as well, and we'll introduce one called the Poisson distribution. So there's several different probability distributions that we'll get to work with. We'll also look at time series data. So that's when we get data that appears to be sort of increasing or decreasing, but there's kind of some fluctuation or some movement around that. And again, you'll be quite familiar with these graphs if you've been watching the television. This is time series, where it's a 7-day time series chart. So every week has the 7 days, and we get that characteristic dip at the weekend, because recording at the weekend is very different to weekdays. So we tend to get a bit of a peak on a Monday, a slump on a Saturday and Sunday. But if we were to average that out and consider the average over those 7-day period, then we can see the trend. And that's where they get that curve that they've drawn into the diagram from. So we'll have a little look at that, and we'll look at how that works and how we interpret that sort of data effectively and how that works. We'll also consider sampling. So it's very rare for us to work with census data. In the UK, we only collect census data every 10 years, and it takes about 10 years to process the data that they collect. In fact, the next one's coming up in 2021, so not far to go for that one. But the results for that won't be available at the earliest until about 2023. So in the meantime, we still need data. So sampling is the way to go, and we'll learn various methods of how to do that effectively and appropriately for the purpose that we want to use the data for. And obviously, we'll have to look at interpreting tables of data, diagrams, some diagrams you won't have seen or met yet. We'll need to look at how they work and what they're actually telling us. A large part of the course, most of the second year in fact, is dedicated to it, is hypothesis testing. Could be known as significance testing, or sometimes it's referred to as statistical inference. It's basically how we go about deciding whether we've got evidence that something has changed or something's stayed the same, in fact. So we collect some sample data, we do some calculations based upon it, and then we can compare those to a given set of values we'd expect to get and decide whether we're significantly different from what we'd expect to see, or whether in reality there is a difference, but it's so small that it's insignificant, that it actually isn't a big enough difference to convince us that something changed. So we'll spend a fair amount of time looking at hypothesis testing. Now, this is probably one of the areas that overlaps most with other A-level subjects. So we'll get to meet a variety of tests, most of which you'll never have heard of. If you have done GCSE statistics, you might be familiar with a few of them. But things like the chi-squared, where we're able to compare whether two variables are related or not. So we might look at GCSE grade against A-level grades and see whether there's an association between those two things. The Wilcoxon tests allow us to compare paired data or two distinct groups of data to see whether their results are different. So we'll compare the mean or the median in those cases. And then analysis of variance is quite a complex thing we do in year 2, but it's actually used in quite a few degree courses, certainly in psychology and biology, and some of the earth science related subjects. So we'll introduce some quite high level statistics on the course that will prepare you for things you're going to meet in your A-level. So we'll do most things in the first year of the stats course that will come up in the second year of your A-level courses, or things that will come up in the first year of your degree course. So generally speaking, we'll meet it first in stats, and then you'll get a chance to reuse it again when you meet your A-level, in your A-level subjects. Okay, so this is an example that's of a graph that's in current use by health visitors and health professionals for monitoring the growth of young children, in this case females. You can see from the scale at the bottom here that we've got coverage from birth to 3 years old, and they go up into monthly increments. We've got the purple graph curve here, which is the 5th percentile, which basically means anybody falling below that is in the lowest 5% of children for their age group. And then the yellow line gives us the 95th percentile, so anybody above is in the 5th percentile at the top, so the top 5% of heights, lengths. And then in the middle we've got the median. That's sort of effectively on average, that's where we'd expect an average person to be. The health visitor will come in and measure the length of the child. Obviously length, because to start with they can't stand up, so they lay them down to measure them. By the time they get to 3, with a bit of luck, they can stand them up, but length at the moment. So we measure it, and let's say we come out at 18 inches. So we've fallen in the bottom zone. So we're sort of below par, we're in the smallest 5%. Now, what will happen over a series of time is the health visitor will measure the child and mark them on the chart. And if they work their way back up towards the sort of main blue zone in the middle, then generally that's considered fine and acceptable and, dare I say it, normal. However, if the child remains in that lower zone, then they will start to investigate whether there's any underlying reasons as to why the child's not growing fully. Is there an issue about nutrition? Is there some underlying medical reason? Or are they just a naturally small child coming from shorter parents and the usual genetic issues related to it? Same applies at the top end. If a child was to lie on the upper white area, then they'd monitor for the same reasons, and if the child continued to always be quite high or even disappeared off the chart too early in their age development, then obviously they'd then look again at underlying issues. Is there a medical condition? There are some conditions that do result in increased growth rate, and they'd need to rule any of those out. So this example actually comes from a genuine exam paper and was also based on a genuine newspaper article. It was actually published in the I newspaper in 2017, so genuine article, and the question was to critique the graph. Now, I'm not going to worry too much about the right hand side because you need to know a little bit about indices, indexes and how they work. So we'll focus on just on that left hand bar charty sort of section. Bar charty because it's not a genuine bar chart. So the students were asked to critique it. So there's a few bits and pieces. Obviously there's a key, so that's good. It's the median hourly rate. So we've got 2005 to 2015. So we can generally see what's going on, but when we start to sort of delve in a little bit more, the scale starts to get a little bit dodgy. I'm not 100% sure what's going on with the school teachers. So we've got a bar of 25 shorter than a bar of 22, and the bar of 25 is much shorter than, about the same size as the bar of 18. The bar of 22 isn't much bigger than the bar of 20. And then if we have a look at prison officers as well, that one looks mighty suspicious as well. The others seem fairly reasonable, though 20 and 19 don't look particularly different in length. So something weird going on. It's not the best graph in the world. It looks like teachers have had an increase in their hourly rate, when in reality they've had a decrease, as is the same for prison officers. And it looks like there's not a lot of differential between the pay of school teachers and the pay of police officers, which actually, according to the numbers, isn't the case either. So it's quite a misleading graph. Now, genuine article presented in the newspaper, quite misleading. And it's not uncommon for articles that appear in the press to be manipulated, intentionally or not, but to be manipulated so that they give the wrong impression. This one certainly does that. Okay, so having mentioned examination papers, a little bit about the assessment of the course. Obviously it's a linear A-level now, as majority are. So internal exam at the end of year one. So that's really to assess how you're getting on, how you've dealt with the year one materials, and an opportunity for you to go back and identify any problematic issues that need to be resolved before progressing to year two. Year two, there are actually 3 examinations, which will take place in the summer term. There's data and probability, which is all based on the probability modelling, averages, interpreting graphs, charts and diagrams. So all the real nitty-gritty number crunching goes into that paper 1. Paper 2 is called statistical inferences. Now that's one of the names I gave, hypothesis testing. So this paper is all about hypothesis testing. So quite a large chunk of the course. And paper 3, very helpfully named statistics in practice, is basically real world stats. All of the papers are in context, but this is basically anything goes. So in this particular paper, they can ask you questions that relate to any parts of the course, and quite often they're sort of 7 or 8 questions that delve into different parts of the course within each of the questions. There's no particular weighting on any of the exams. 1/3 of the marks go to each of the exams and we just get a total. And there's no coursework in the sense of any examined coursework. Now, obviously, this year's been a little bit different in terms of there were no A-level exams either. Not quite sure what the future brings for examinations, but as it stands, the situation is we will be assessed via these 3 exams. So we do quite a bit of number crunching on the course, but we couldn't do that without our graphical calculator. Some of the calculations are very long-winded to do by hand, and in the real world you'd use a spreadsheet or a statistics piece of software to do it. So the exam board have an expectation that you'll use a calculator. The model we use is the FX9750G2. We've got extensive resources developed around that particular calculator. It isn't a cheap piece of kit. It is around the sort of £55, £56 mark at the moment. That is obviously subject to change. But we do keep a stock in the college stationery shop. If you're very keen on doing stats next year and you know you're very likely to be doing it, then it is possible to have a little look around on some of the better known marketplaces on the internet and potentially pick one up, but obviously be mindful. If it's not a new product you're picking up, it won't be under warranty. If you're potentially looking at doing A-level maths as well, this is not the recommended calculator for A-level maths, but it will do the job that you need it to do. It actually lies between, there's a basic maths one and a more advanced maths one, and it lies in the middle between those two. So it meets the basic requirements and exceeds those, but doesn't quite meet the more advanced and much more expensive requirements of the higher level one. Okay, so statistics maths. I've mentioned maths, I've mentioned statistics. They're worth the same. In terms of university entry points, any A-level is worth the same number of points. You would need to look carefully at university requirements as to whether an A-level maths is needed or preferred, but statistics certainly in some cases would count as a science and potentially would be able to replace maths, but not in all cases. Is it easier than maths? Well, it depends on your point of view. If you find the algebra of the maths, the pure element of it, more challenging, then there's a lot less of that in the statistics. There's a little bit of algebra in there, but not a huge amount. And we do help you work through that. What I think probably in statistics is more challenging than in maths is probably the problem solving, the interpretation and the analytical side. And there's more of that in statistics than you do get in the maths course. You can do statistics at degree level. There is a statistics course. There's also other courses that have statistics in them, so psychology and statistics, business studies and statistics. There's joint degree courses. So yes, you can do. What you need to be careful about is quite a few of those courses will require that you do A-level maths. Now you can do A-level maths and A-level statistics, but obviously if you're looking at 3 A-levels as opposed to potentially 4 A-levels, then that takes up 2 of your A-level choices. You need to be quite definite that that's the field you want to go into. We do have a number of students every year who do both maths and statistics alongside each other, and obviously they support each other brilliantly, and students tend to do very well when they do 2 subjects together, but it does take up 2 of your subject choices. When the review took place in 2016-17, A-level statistics was on the brink of disappearing, and a lot of people worked very hard to keep the A-level statistics running, and the Royal Statistical Society are a very big backer of the A-level stats, and they do see it as part of that pathway alongside the maths and the core maths as a sensible choice for A-level students. And finally, we thought we ought to let our students have the last word, so a few quotes from our students. Okay, so that concludes our little tour through statistics. Many thanks for your time. Best of luck for your results and have a good summer.